Good afternoon, and welcome to the seminar on the particulate matter problem, including Haze in Southeast Asia, organized by the EANET. My name is Ken Yamashita. I'm the head of the Planning and Training Department of Asia Center for Air Pollution Research, ACAP. I work at the Network Center for the EANET, hosted by ACAP, and I'll be facilitating this session with our esteemed guests and colleagues. Today's session focuses on sharing knowledge about the particulate matter problem, including Haze in Southeast Asia with EANET participating countries and beyond. The objectives of this seminar are to discuss and make recommendations, if possible, the possibility of near-future cooperation, especially on the second roadmap for ASEAN cooperation on transboundary haze pollution control with means of implementation, ASEAN haze-free roadmap. To discuss the various effects on ecosystem and human health by PM haze pollution, to obtain scientific knowledge on the relationships between the atmospheric environment and human health, including epidemiological methodology and between the atmospheric environment and ecosystem, and to run science-based policy experiences and practices in other regions, such as Europe. The seminar will be divided into two parts. The first part will focus on presenting the PM problem in atmospheric environment in East Asia and its effect, and include 3 experts' presentations, followed by a question and answer. Among our experts today, we are very pleased to have Mr. Wiraditma Prananta from the ASEAN Secretariat, who will present the transboundary haze pollution in Southeast Asia, ASEAN Haze-Free Roadmap 2023 to 2030, and its monitoring and evaluation, followed by Mr. Chong-Wee Chia from the ASEAN Specialized Meteorological Center, who will explain the smoke haze dispersion model at the ASMC. Then we'll have the pleasure to hear Dr. Eric Zussman from the Integrated Sustainability Center Institute for Global Environmental Strategies explain the enabling the implementation of haze pollution solutions in Southeast Asia. The second part of the seminar, facilitated by my colleague, Dr. Yusuke Kiriyama, Senior Researcher of ACAP, will focus on the scientific knowledge on PM pollution in other regions. In this session, we will have the pleasure of welcoming Dr. Jan Eyof Jonsson from the Meteorological Synthesizing Center west of EMEP, a Norwegian Meteorological Institute. He will introduce the modeling and measurement of regional PM pollution in Europe. The presentation will be followed by an interactive discussion and by closing remarks from our colleague, Dr. Toshimasa Ohara, the Director General of ACAP. We hope you enjoy the program and please do remember, we will be looking for your comments and questions in the Q&A box, question and answer box. Before we move forward, I would now like to invite Professor Fan Mem, Deputy Director General of ACAP, to share the welcome remarks. Professor Mem, the floor is yours.
Thank you, Dr. Ken Yamashita. Dear Mr. Ber Fabian, the Secretary of EANET, Mr. Wiraditma Prananta from ASEAN Secretariat, distinguished participants of the seminar, good morning and good afternoon. So on behalf of ACAP, the Network Center of EANET, I'm honored to open this important event, the EANET seminar on the PM problem, including haze in Southeast Asia. The seminar brings together distinguished government officials, scientists, and experts from across the region and beyond, and from other regional networks and international organizations. Today, we gather to address pressing issues that are affecting billions of peoples and the health on our ecosystem, the PM problem, including the haze caused by the fire. The EANET and ASEAN Agreement on Haze Pollution, also called AATHP, have long been at the forefront of tackling this challenge. The overlapping natures of our region and shared target substance call for a more integration approach. Our seminar today aims to foster cooperation between EANET and AATHP among scientific community and stakeholders for control PM and haze problem in the region. Leverage our collective knowledge and expertise to enhance the scientific research and develop effective science-based control policy in the region. The seminar will discuss the possibility of cooperation in the near future and among the EANET and second, the roadmap of ASEAN cooperation in transboundary haze pollution. We will explore air pollution emissions and atmospheric physical and chemical mechanism and process affecting the air quality to examine the various of impact of air pollution on human health and our ecosystem, as well as intricate interaction between air pollution and climate change. By sharing scientific knowledge and science-based policy practice experience from other regions, such as Europe, we hope to gain valuable insights that can be applied to the Southeast Asia region. I believe those cooperation and information are very important and also useful for the other EANET member country in Northeast Asia. I would like to extend a warm welcome to all the participants. Your presence here today is a testament to our commitment to improving our atmospheric environment and safeguard public health. I encourage you all to engage activities in the discussion, share your insight, and collaborate together toward our common goals to achieve a haze-free and healthy environment for all. I look forward to productive and enlightening seminar. Thank you very much.
Thank you very much, Professor Mem, for your welcome remarks and for introducing today's seminar's objectives. Next, I'd like to invite Mr. Bart Fabian, coordinator of the Secretariat for the EANET, to deliver the opening remarks. Mr. Fabian, the floor is yours.
Dr. Yamashita, Professor Mongfan, NC colleagues, Dr. Ohara, our esteemed guests, and also distinguished speakers, good afternoon. It is a pleasure for me to contribute to this opening session, also on behalf of UNEP Regional Office for Asia Pacific, who is hosting the Secretariat for the EANET. This issue on particulate matter air pollution and haze is very important for Southeast Asia. I'm afraid over the last 5 years, there has been high levels of air pollution from particulate matter, but also haze, particularly in the Mekong region, the northern Mekong region. But also there are still problems of particulate matter air pollution in other parts of Southeast Asia, particularly in Jakarta, in Hanoi, also in Metro Manila. We see this. And sometimes it's important for us to understand really the sources, the contributions of these sources, the influence of weather, meteorology. And I believe that through EANET, its network of scientists, government officials, but also other intergovernmental bodies, particularly the ASEAN and other entities, we will be able to help in assisting to reduce or eliminate this problem of particulate matter air pollution and haze. Maybe it's wishful thinking, but there is no other way except for us to work together really and try to solve this. My colleagues have already mentioned how many people are affected by air pollution, particulate matter in this region. And I'm afraid it will only increase in the future because this air pollution problem will probably remain. We know that urbanization, motorization, demand for more energy directly impacts use of energy and emissions. And as such, as many of the countries in Southeast Asia are sustaining high levels of economic growth, this may continue in the future. But perhaps through these efforts, our collective efforts within the UNEP, within EANET, within the ASEAN, other organizations, we are able to contribute to reduce this problem. I will stop here and I wish you all the best for the rest of the afternoon. I'm sorry I will not be able to stay throughout the whole session, but my colleagues are also here. And yes, good luck and I hope for fruitful discussions. Thank you very much.
Thank you very much, Mr. Fabian, for your welcome remarks. Now, I'm pleased to invite our next speaker, Mr. Chong-Wei Chia, who is an executive meteorologist at the ASEAN Specialized Meteorological Center. He is an expert for atmospheric and oceanic sciences. He applies dispersion model and numerical analysis to understand and forecast airborne hazards in Southeast Asia. Mr. Chia, you have 10 minutes for your presentations. Hopefully this is fine for you. Mr. Chia, the floor is yours, please.
Thank you, Dr. Ken Yamashita. Good afternoon. I'm Zhongyi. So today I will present about the smoke haze dispersion modeling in ASEAN Specialized Meteorological Center, ASMC in short. So I will go to the next slide. Some acknowledgement on the work. This dispersion modeling system was started in 2013. So the first generation of modelers have contributed significantly to the R&D of the system. Although they are no longer in service, here's a small token to acknowledge their hard work and contribution. I have the honor to work with them, but I consider myself the second generation of modelers in ASMC. So next, I will give an overview of next slide. I will give an overview of our dispersion modeling system. So to forecast the spread of smoke haze, we need the sources of predictability. First of all, we need to know the location of fire hotspot and the corresponding emission. Then we need the weather forecast, particularly the wind information. And we feed the fire emission and weather forecast into our dispersion models and run the model to forecast haze. So model is never perfect, so it must be interpreted together with observation. We are also gathering observation from air quality ground observation, weather and hotspot location as informed by our satellite. Our operation meteorologists will interpret and assess the model output and observation. So this is how the advisory are made in ASMC. So in the next slide, I will describe about basic modeling of smoke dispersion. So here are a few fundamental steps in dispersion modeling. First, the model need to know where the emission are and what's the amount of pollutant being emitted and how high this pollutant can reach in the atmosphere. Then, the model use weather forecast to determine the spread of smoke haze by the wind. So in this process, chemical reactions happen and our pollutants will react with other chemical species in the atmosphere. And our model account this process by its own chemical scheme. So in the next slide, I will talk about UKMO name model. So this is the model SMC use. So it's called numerical atmospheric dispersion modeling environment. So it was developed by the UK Met Office after the Chernobyl nuclear incident in 1986. So we have been partnering with them since 2013 to develop the model for use in Southeast Asia. Name model is a Lagrangian model with chemistry scheme. In our system, we primarily forecast for PM2.5, PM10, and aerosol AOD. So for fire emission, we derive the emission from CHEM's GFAS product together with our in-house land cover map. For weather forecast, we obtain the forecast from ECMWF deterministic forecast. Next slide, I will talk about wildfire emission. So our wildfire emission are basically derived from fire radiative power or FRP. FRP inform about our radiant heat output of all the detected fires. Martin Wooster et al. Have demonstrated that this variable can be used to deduce fire emission when combined with land cover map. The process is as follows. From the location of hotspot, we determine the land cover type at that hotspot. Then given the land cover type, we can select the corresponding specific conversion factor and specific emission factor. These are the two parameters we use together with FRP to determine our wildfire emission. So the specific conversion factor informs how much organic matter is being burned given the FRP. And then the other factor, the specific emission factor, inform how much emission are being generated given the amount of organic matter being burned. So these are how we estimate our wildfire pollutant. So in the next slide, I will talk more about FRP. So for FRP, we retrieve from the CHEM's GFAS system. Other than FRP, we also retrieve the plume height information from GFAS. So it basically tells us how high the pollutant can reach in the atmosphere. GFAS product is at 0.1 degree spatial resolution, and we assume that the burning situation persists into our entire forecast time horizon. Next, I will talk about the land cover map used for our wildfire emission. Our land cover map is developed by the Center for Remote Imaging, Sensing and Processing, CRIPS, in the National University of Singapore. So the land cover map is used to select the appropriate specific conversion factor and specific emission factor for estimating wildfire emission. These parameters are compiled from the literature by our partner CRIPS. Next slide, I will give an example on the model performance. So here's an example of a forecast during the September 2019 Haze episode. So at the left side, you see a horizontal field of surface PM2.5 concentration. At the right, you see 2-time series. The blue line is our forecast. So we verify against the gray line, which is the observation done at ground level in Singapore. So you can see that the model generally is able to distinguish between haze and non-haze period. But when it comes to predicting the peak and also the exact magnitude of the PM2.5 concentration is never perfect. Sometimes we have heat, just like the first circle at the left. Sometimes we have false alarm, like the center circle, and sometimes we have misses, like the last circle at the right. So in the next slide, I will talk about why smoke haze dispersion modeling is difficult in the tropical region. So first of all, we recall that our model's source of predictabilities come from the correct estimation of fire emission and also our weather forecast. So we rely on the accuracy in these two data set to make a reliable forecast. And in our tropical atmosphere, very thick clouds are prevalent. So they can obscure the detection of fire and haze. So this poses some challenge to our correct estimation of wildfire emission. And secondly, The tropical weather system have a lot of transient and small-scale phenomena. For example, the localized thunderstorms. These are harder to predict compared to the large-scale and long-lived weather system. This again give us some challenge to produce a more accurate weather forecast and hence a more accurate haze forecast. Also, to understand our model performance, we need observation. In our region, there's not sufficient coverage of ground station. So this poses another challenge. Besides, a significant part of Southeast Asia is covered by sea. So it poses some issue for us to set up more ground station observation as well. So with that, I kind of conclude my presentation, and thank you.
Thank you very much, Mr. Chair. Again, if there are any questions for Mr. Chair, please type them in a Q&A box, and we'll try to answer these during our Q&A session after the presentations. Now, I'm pleased to invite our latest speaker in the session 1 for this first session of the seminar, Dr. Eric Zussman, who is a research director at the Institute for Global Environmental Studies in Hayama, Japan, and who will share a presentation on enabling the implementation of haze pollution solutions in Southeast Asia. His expertise are public policy and Asian studies in political science. For much of the past 2 decades, he has conducted research on environmental issues in Asia. This has included working with China's Yellow River Conservancy Commission, the Chinese Research Academy on Environmental Science, Woodrow Wilson Center's China Environmental Forum. He was a lead author for the 6th assessment report of the Intergovernmental Panel on Climate Change. Dr. Zussman, you have 15 minutes for your presentation. Hopefully this is fine for you. Dr. Zussman, the floor is yours.
Okay, thank you very much, Ken and colleagues, and do appreciate the opportunity to present at this important meeting. And I hope everybody is well as we approach the end of 2024 and enter 2025. As Ken mentioned, the title of my presentation is Enabling the Implementation of Haze Pollution Solutions in Southeast Asia. And I'm going to start off with a little bit of framing remarks, which have already been offered elsewhere, but I think will be important to highlight the salience of the issues that we're talking about today. I mean, I think this transboundary haze issue, of course, has been an important issue and persistent problem within the region for more than 30 decades. Excuse me, not 30 decades, 3 decades. But at any rate, with the growing severity of climate change and its possible feedback loops with haze, I think this is going to be something that the region grapples with for some time. And I think one of the keys is really how do we set up not only an agreement at the regional level, but also at the national and local level to address these issues. So this is a reoccurring challenge. And sometimes, as we saw, for instance, in 2015, that challenge can cause a set of crises. And I think as we're also seeing, it's becoming more of a challenge in the Mekong region, Northern ASEAN region. And so to try to adjust that challenge, there's been, has already been mentioned, a Haze agreement that was ratified initially, or excuse me, signed by all AMS in 2002 and then ratified in 2015. And then moving forward, after the agreement was ratified, there have been 2 sets of roadmaps that have been put in place. The first roadmap ran from 2016 to 2022. And then the second roadmap, as I'll talk about in greater depth shortly, is running from 2023 to 2030. And the roadmap provides a series of different strategies that can help implement some of the key provisions in the Haze Agreement itself. And so moving forward, one of the things that we want to do in order to operationalize this roadmap is really to tackle some of the emerging issues with Haze. And some of those emerging issues will be focusing a lot on the Mekong region. So you can get a sense that, the monthly hotspot counts in the Mekong region are high and increasing over the past 5 years. And especially with some of the El Nino weather patterns, they appear likely to become more intense in some parts of the region. Now, in terms of trying to tackle these issues, this new roadmap really outlines a sort of new set of approaches and a new set of strategies. So as was already mentioned by Weera, the roadmap consists of 9 separate strategies. The core of the roadmap is the implementation of the Haze Agreement itself, and the enhancement of the ACC-THPC, which is going to be opening in Indonesia. But there's also several other unique features that are interesting about the roadmap. 2 of those unique features are these 2 new headline targets, one of them focusing specifically on PM 2.5 itself, so on fine particulates. And I think that's a step in the right direction, in part because the haze pollution itself, of course, is coming a lot from forest fires, but it's also coming from other sources as well. And there's also sometimes a mixing between pollution from different sources. So by targeting PM 2.5, in addition to the number of haze pollution episodes itself, I think is setting the agreement in the right direction. And I will suggest also that as I outline these key features, this is based upon some of the work that my institute, IGES, in collaboration with colleagues from Thammasat University did to help the AMS agree on the sort of structure of the new roadmap. Some other additions to the new roadmap that I think are worth highlighting, and were also suggested by the presentation from Weera. So first of all, there's a growing emphasis on evidence-based or science-based goals, and some stronger alignment with air pollution WHO targets. There's greater emphasis on different types of pollution control instruments, especially economic instruments. So using subsidies, for instance, to encourage farmers to switch to different types of equipment that will reduce the haze. And there's also a greater emphasis on what I would call a more integrated development view. So if you look through some of the over 60 actions that are outlined within the 9 strategies of the roadmap, there's references to climate change, the SDGs, as well as the ASEAN Community Blueprint. And then I think some of the other things that you'll notice is there's a greater emphasis, and I'll talk a little bit more about this as I move through my presentation, on what I would call multi-level, multi-stakeholder approaches, or multi-level, multi-stakeholder governance. So there's a recognition, for instance, that to implement provisions within the roadmap, that a lot of that action isn't going to happen at the local level, or within different communities. And I noticed also there was a question from Mark Broomfield about, engagement with the business sector. So there are provisions on some actions within the roadmap about engagement with private sector. At the same time, there's also recognition that, for instance, at the local level, there might not be sufficient capacities to implement everything. So this multi-level approach allows for, resource transfers from the national level down to the local level to help implement things or help scale up things. Then last 2 points, there's this much more of a sub-regional approach. So as I mentioned previously, the emphasis on especially the Mekong region, the Northern ASEAN region, is much more pronounced, in my view, in the roadmap. And this is also reflected to some extent in the fact that the sources of haze are different within the northern and southern ASEAN regions. And then there's much more emphasis on interlinkages and networking across different types of agreements, climate, biodiversity, and air pollution. And I think this aligns well with the growing emphasis, for instance, on synergies between climate, biodiversity, and many other development issues. You also see a similar type of approach being echoed, for instance, from UNEP when they talk about the triple planetary crisis. So all of these different elements, I think, are emphasized in the new roadmap and definitely reflect a step in the right direction, in my view. Now, in terms of actually implementing some of the provisions in the roadmap, and in particular in terms of implementing solutions to open burning, I'm going to turn gears here a little bit from the roadmap specifically to some research that my institute has done on open burning and open burning controls. And one of the things that we're most interested in is some of the challenges to implementing, especially, if you look at some of the legislation on open burning, a lot of times the legislation basically says, there should be a prohibition or absolute restriction of the practice. Well, what we've, noticed is there are barriers to implementing those types of prohibitions and restrictions. And what we've also done is some, what I would suggest is relatively forward-looking research on analyzing the magnitude of those barriers. So we break up our barriers into open burning prohibitions into 4 categories: technological, whether or not there's access to different technological solutions, and then different types of infrastructure that help implement those solutions; economic, this refers to the costs of cleaner solutions or cleaner technologies, as well as different types of policies that would perhaps promote dirtier options or more resource-intensive options; institutional, and I'll focus a lot on this issue because it gets into some of the governance things I'll talk about later, but this refers a lot to coordination across different agencies or capacity within agencies to implement restrictions on burning or other solutions; and then social, and this refers to the awareness levels of some of the users, especially farmers, as well as the acceptance of different types of solutions. So these type of barriers, I would suggest to you, can stand in the way of solutions to open burning and also to solutions to other key pollution problems in Southeast Asia. And so what we've done to try to understand the size of these barriers is we've done surveys. In the case of, I'm going to show you some results from Thailand. We're beginning to spread out to other parts of the region as well. But what we've done is done surveys to try to understand what are the size of different barriers to implementing key solutions in Southeast Asia to air pollution, with an emphasis on open burning. So you can see in the middle here, we have control open burning, and then we have these different types of barriers. The green and the yellow are the social institutional barriers, and the blue and the red are the technological and economic barriers. And what I would suggest to you is from these survey work is that some of the key barriers to implementing open burning solutions and also many other air pollution solutions in Southeast Asia are social and institutional in nature. And from that survey work, we're also able to estimate what might be the delays in implementing certain controls like restrictions or prohibitions on open burning. And once we are able to estimate those delays, we're then able to feed that back into some of the modeling that's been done on open burning restrictions. And so what I'm going to show you then is, when you actually begin to feed in some of these social institutional barriers back into your modeling, what that looks like for the case of Thailand and the case of PM 2.5. And what I'm showing right here is basically, 2 results for some of the modeling that's been done on open burning with and without barriers. And here we're focusing on the social institutional barriers. And basically what I'm suggesting to you is that if you don't have good enabling environment, if you don't have a good set of institutions in place and a good set of awareness raising programs, what you might be able to get from restrictions or prohibitions on open burning are not going to be sort of the full mitigation potential. So the reductions from some of the barriers, there's about a difference between a 75% reduction and a 50% reduction. by 2030. And once again, this is based upon Thailand case. And 2040, it's the difference between a 70% reduction and a 50% reduction. So basically half of, or 40% of the battle is putting in a set of enabling environments that will support the implementation of open burning solutions and open burning restrictions. And so this got us to a second question is, so how could we overcome these barriers in Thailand case? So part of this, we decided to move even further with some of the quantitative analysis. So working with our partners is one of the things we asked is what would be the needed increase in budget. And when I say budget here, I mean public resources that would be allocated to help enforce or support the implementation of open burning restrictions and other solutions. And so what you see here is an estimate of the additional budget that would be needed to effectively implement some of these solutions. And the additional budget part is that sort of dotted, polka dotted, or thatched red that you see running from 2024 to 2034, once again, in the Thailand case. And so this gave us some sort of quantitative estimate of some of the things that you might want to do. And then there's also, of course, some qualitative things that can be done to sort of supplement restrictions on burning. And, this will require focusing on things that sort of are not necessarily technical solutions, but also, supporting some of these technical solutions with awareness raising. So for instance, when we talk about stubble plowing during rice cultivation, making sure that there's also a social dimension to that, making sure that there's also awareness raising and capacity building support to drive home some of these solutions. And then similarly, and this goes back to the roadmap to some extent, also recognizing that many of the solutions themselves have other purposes or deliver on other development priorities. So for instance, when we begin to use crop residues for other purposes, underlining some of the additional development benefits and building stakeholder support by underlining some of those additional development benefits. Okay, so the last point I want to get to is in terms of some of the governance issues. And this comes back a little bit to, some of the institutional barriers, and also comes back to some of the provisions in the roadmap, focusing on a sort of more multi-level, multi-stakeholder approach. And I think the key thing that I'd like to underline here is when we think about upscaling sort of successful solutions to open burning, there's two different governance models that might help us work here. One, which is the one that I think many people think of when they think of, sort of multi-level, multi-stakeholder governance, is this sort of blocked figure where you can see working across different types of sectors, economic, environment, social, or even within those blocks, there's different, sectoral or siloed divisions. And then providing incentives not only to work horizontally, but also to work vertically from the national, regional level down to the local level. So that's part of the story. And I think there's been a lot of emphasis in the governance literature on creating mechanisms that create incentives for cooperation across those silos or across those different levels, especially to scale up some of the successful solutions to open burning. The other approach I'll call polycentric. I mean, this is coming a lot from, I think many people here are familiar with the work of Eleanor Ostrom. And her view is that, different levels and different governance units don't necessarily, are not necessarily cleanly divided like you see on that initial diagram. In fact, there tends to be a lot of overlap between the mandates and remits of those different organizations. And especially at the local level, one of the keys to trying to inspire innovative solutions and then also to scale up things is to, rather than to focus a lot on coordination, is to create opportunities for competition and competition between different units of governance to come up with solutions. And then once you have some sort of successful approaches, then you can begin to scale those things up. And so, Ostrom's view is a little bit more, if you will, a little bit messier. But by creating sort of the opportunity for different types of approaches to sort of spring up from the bottom and then to scale that way, might also offer opportunities to address some of the challenges to open burning, especially some of the institutional and social challenges, and to do it at a lower cost as well. So I'll leave it with that. But thank you very much, colleagues, for allowing me to present on some of the work we've done on the roadmap and some of the research we've done on implementing solutions.
Thank you very much, Dr. Guzman. So we have 6 questions from the audiences, but not so some questions for first speaker, Mr. Prananta, and also some questions for second speaker, Mr. Chia. So here, I would like to ask the answer for 2 speakers so far. And questions 4, 5, 6 for Mr. Chia. So, Mr. Chia, could you reply to this question?
Sure, Dr. Ken Yamashita. So, Krishna Santo, nice to meet you. Yes, the challenge that you face is commonly shared. So, ground air quality observation is generally sparse in our regions. So, AOD is a potential substitute for it. So, the questions become how you convert your pollutant concentration to AOD. So, if your chemical transport model can generate AOD output directly, I think you can compare your AOD with the satellite observation at your hand. So if your model couldn't, then perhaps you can use a radiative transfer model to calculate the AOD. So RT12 is a free radiative transfer model that you can consider. So they are free and openly available, open source. So it's good for research as well. So so for your follow-up questions, I think validation from the ground is great, but they are not the perfect truth because we heard from our collaborators that some of the measured PM 2.5 spike may come from cooking activities as well. So they see a diurnal pattern that during the cooking, the time when the housewife cook their meal, and then they see a spike in their sensor, and they went to the ground and made some investigation. So they find out that okay, some cooking process may affect your ground level observation as well. So it's complicated. They are nice, but they are not perfect. So so I would say AOD would be great. If you search the literature, you will find that there are significant number of work actually validate their model using AOD. So I think it's perfectly okay to use AOD. So for satellite AOD, I would recommend MODIS because it has been around for more than around 20 years. So you have a lot of data, observation data for you to understand your model. So for the last questions by Miss Yami, so the because our name model is a Lagrangian model, so it's not like you don't understand the spatial temporal resolution in a Eulerian sense. So but we do carry out our chemical reaction on a Eulerian grid, and that grid is like 0.25 degree. That's what we use. So for initialization and configuration of our model, right? So we do a cold start for 7 days spin up. And then for configuration, our chemistry scheme is called every 15 minutes. So for that, I hope I address your question.
Thank you very much. It's very nice, nice question and informative answer from the two speakers today. So far, we don't have the question from followers for the Dr. Dussman, but I have one question for Dr. Dussman. Through the presentation from the three speakers for the second haze-free roadmap. So this is only the problem of the air pollution, the PM or haze problem, but also for the very related to the climate change problems. Because the haze or PM is very related to that SLCP, as known as SLCP. So, Dr. Dussman, do you have any specific ideas which is the most important relationship between the haze problem and the global warming, or the co-benefit in the term of the co-benefit for this region?
Thanks, Ken. So I mean, I think in the context of the haze-free roadmap and this transboundary air pollution discussion, I mean, I think a lot of the emphasis was on, you know, how a warmer climate would contribute to drier conditions and would lead to more burning, basically. And I don't think there was as much emphasis, for instance, on the short-lived climate pollutant argument that you're suggesting, or you know, the fact that when you burn forests or biomass, that it releases. I mean, it releases both BC and organic carbon. My impression is part of the reason that part of the discussion wasn't emphasized as much is the history of the Haze Agreement was really built around, forest fires. So you have a strong emphasis on people coming from the forestry community or the agricultural community, and not as much from the air pollution community. Having said that, I think there are opportunities, and I think we're seeing a growing amount of opportunities for collaboration between folks that work on forest, agriculture, and then, on the air pollution and climate change side of things. And I think, one possibility in the future, I know that, EANET and the CCAC and the SCAP under REPAP and UNEP under APCAP. I mean, I think there's a lot of potential to bring together the folks that are working, more from the forestry and agricultural side and the air pollution and climate change side, both to understand the potential for, solutions and also understand the impacts a little bit more. And I think that type of discussion also will facilitate discussions within, environmental ministries or across environment and agricultural ministries. I think that type of discussion is really important to come up with a more holistic, integrated type of set of solutions. So the short answer to your question is that I don't think those points are emphasized that much, but I think there's a lot of scope to push that discussion in that direction moving forward. And I look forward to seeing folks from ACAP and EANET facilitating some of that discussion too. Thanks.
Thank you very much. Very informative. So far, all questions were answered by the speakers. And Mr. Prananta emphasized that the AHHP, for second haze-free roadmap, will be implemented by supported by such as the Clean Air Sky strategy and Haze portal or any other activities. And also the Mr. Chia Mr. Chia presented the smoke haze dispersion modeling supporting the second haze-free roadmap by the scientific evidence. And also the Dr. Dussman presented that the second roadmap will be implemented by the four various approaches such as technical, economical, institutional, and social aspect challenges for the solutions. So those presentations are very impressive for us, I think. So then the first session of our seminars is now over. So let's move on to the second part of the seminar on the scientific knowledge of PM pollution in other regions. I'd like to invite Dr. Yusuke Kiriyama, a senior researcher of ACAP, to facilitate this session. Dr. Kiriyama, please.
Thank you, Dr. Yamashita. Good afternoon, all participants. My name is Yusuke Kiriyama. I'm a senior researcher in the Data Management Department of ACAP. I work at the Network Center for the EANET hosted by ACAP, and I will be facilitating this session with our esteemed guests and colleagues. I will do my best to ensure that we successfully complete the remaining session for today. This session will focus on scientific knowledge of PM pollution in other regions and include one expert's presentation followed by a Q&A. We hope you enjoy the program, and please do remember we will be looking for your comments and questions in the Q&A box. Now, I would like to invite Dr. Jan Eyolf Jansson from the Meteorological Synthesizing Center west of EMEP, Norwegian Meteorological Institute, and who will share a presentation on modeling and measurement of regional PM pollution in Europe. Dr. Jan Eyolf Jansson from the Norwegian Meteorological Institute, where he has been a dedicated scientist since 1993. Dr. Jansson's expertise lies in atmospheric chemistry with a particular focus on tropospheric ozone, the effect of ship emission, hemispheric transport of air pollution, and the impact of wildfires. His research themes include photochemical oxidants, acid deposition, and heterogeneous cloud chemistry. Dr. Jansson's work has significantly contributed to our understanding of these critical environmental issues. So, good morning, Dr. Jansson. I believe you are joining us from a different time zone. It is a pleasure to welcome you today. We have allocated 40 minutes for your presentation, and the floor is now yours. Over to you, Dr. Jansson.
Well, thank you for the invitation. Yeah, I'll just start by sharing. Let's see.
Okay, now we can see yours, right?
Okay, that's good.
Go ahead.
Yeah. Okay, yes. So I'll talk a little bit about what we do in Europe with the LERTAP convention, which is linked to the UNECE, So I'll talk a little bit about how this is organized, and I'll show some results from our reporting, and I will also show something about what we do with wildfires. So actually, this LERTAP convention and the EMEP centers was actually started already in 1979, partially because at that time acid deposition was a big issue in Europe. And there are actually something like 51 parties to this convention, so it's basically all the countries in Europe, including Russia. So the countries actually extend all the way through to the Pacific. And also, actually, US and Canada are also parties to this convention. The organization of the convention work is we have these centers where MSc West is responsible, among other things, for particles, ozone, acid deposition, and those sort of things. And you have SIPE, which is responsible for the emissions, and you have MSc East, which is doing work on persistent organics and heavy metals, and so on. And there are also groups or working groups, like one of them, which I would like to emphasize, is the task force on hemispheric transport, which also extends into Asia. So I can show you the next slide. So this is actually something that I think would be very relevant also for your region, where right now there are several initiatives in this region where people are asked to do model calculations. So there are quite a few European, North American, and so on, both global and regional models that are going to take part in this. And as I say, one of the key questions also for HTAP is actually the effects of wildfires. So Met Norway is as we are the MSc West, hosting the MSc West Center, we are doing a lot of things. We are looking into trends. Do we understand the trends? One important thing is that has been a focus for some while now is the importance of condensables, which means that, for instance, sometimes on a hot smokestack, what is sort of emitted in the actual stack as gases will sort of immediately condensate to particles, and it's sort of difficult to know from the emissions, because the practice for how this is reported, or what type of emission this is reported, varies between the different countries. And of course, we are trying to evaluate how this how the concentrations and parameters, how what's the distance between the current status and the WHO guidelines. And of course, how will this change to year 2030 and beyond? And of course, all this is sort of the goals and so on are part of the Gothenburg Protocol, which is a protocol to abate pollution in Europe. This was actually amended in 2012, and there will be further amendments coming along. And I should also say that the way this protocol is working is that you look at a sensitive, the most sensitive region is sort of setting the goals, because if your country contributes to an area that are above the goals, then you have to reduce more than someone contributing to an area where there's little or no exceedances. So the requirements are somewhat different for different countries or regions. Requirements for reductions. What do we do? Every year we produce a sort of an annual report where we sort of sum up the status and we look at trends and we see how the situation is in terms of meeting the goals and so on. And we also calculate what we call source receptor matrices, which is an important sort of issue, because then you can see to what extent one country will contribute to the pollution in other countries. And you should bear in mind also that many of the countries in Europe are rather small in area, so the effect of transboundary concentrations can be often much larger than the actual national contribution. And of course, the report will also and we will also have an evaluation where we have an extensive measurement network, even though there are shortcomings in this network. So the report or the reporting work will, of course, have a large part of evaluation of model results to the measurements. And of course, we also look at the effects and so on. So here are some examples. So you see, this is the top figure shows the PM 2.5 concentration, and the triangles on top of that are the concentrations at some measurement sites. And these are all, I should say, these are all annual measurements and annual concentrations. And then the figure below shows the actual exceedance days, number of days that the standards are exceeded. Of course, as this has a sort of a threshold, the correspondence between the number of days are not quite as good as when you look at the concentration itself. And we also have some looked at some measurements where we have speciated results for PM 2.5, and the top line of figures the measurements, and below you see the calculated speciated concentrations. And what you see is, especially for if you look at the top bottom left figure, you see that sometimes the concentrations are and it's especially the organic matter in this figure is not the measurements and the model results are not in correspondence, and we believe this is mainly due to wildfires in this instance. And you also see that the speciated results and the total PM measurements are not always exactly the same, because it's not exactly the same measurement. And again, some results from the national reports. As I said, we actually produce one report for each country every year. And this particular example is from Croatia, where we look at where does the PM 2.5 actually come from. And then in terms of country, so you see the largest contribution is actually from Croatia to itself, but also a major contributions from neighboring countries. And actually the biggest contribution is maybe the other countries, because as I said, Europe is a region with relatively many small countries, so there are a lot of sources from many nearby countries, and also these results are tabulated in the main report for all the countries. And the bottom right figure actually shows the concentration of PM 2.5 and also the fraction, which actually is from more natural sources like sea salt, mineral dust, and so on. As I said, we also do calculations for trend calculations, and of course then we need also the emissions and how they are changing. So you can see that there is some difference between both the species. You can see that in particular the sulfur emissions have gone down quite substantially. And this is from year 2000. And of course, especially for sulfur, the reduction in emissions started quite a bit already from the 1980s. So the reduction, especially in sulfur, is really large. But you also see that there is some difference between the eastern part of the countries and the western part. So you can see that in the western part the reductions are larger than in the eastern part, and also the emissions in nearby regions like Northern Africa and near Asia, they are actually increasing. So how is this affecting the concentrations? Here we look at PM10 and PM 2.5. So what you do see is that the reductions in emissions have actually led to quite marked reductions in concentrations. So you see, for instance, over the period, both PM10 and PM 2.5 has increased by something like between 35 and almost 50%, depending on a little more for PM 2.5 than PM10. And you also see that there are sort of reductions every year and for every season. And of course, one of the reasons why PM10 has not been reduced to the same extent as PM 2.5 is that there's a larger sort of natural contributions to this to the coarse fraction of PMs. And also even though the calculated and measured levels, at least for PM10, differ, at least the trend is very similar for both measured and model calculated trends. So what do we expect to happen in the future? So there are different levels of ambitions. So if you have the depending on what you have the base, which is sort of what has already been decided in the legislation, and then you have, for instance, the maximum what you can achieve with sort of maximum measures, and then you can see that the PM 2.5 levels are expected to decrease in basically all regions in Europe. What we'll look at here is the green is the EU countries and the EFTA countries, and the red is the Western Balkan countries. These are mainly not members of the European Union, and the ECA countries, which is basically the former Soviet Republic countries, except the Baltic countries, which are part of the European Union. And on the right, you also see that the exceedances of health levels and so on is expected to at least decrease quite a bit in the coming years in Europe. So if you go to the fires, there are most of these, or the backbone, I would say, of the fire measurement or measurements are from the MODIS satellite products, and there are two types of ways of calculating the fire emissions. One is from active fire products, which is basically the fire radiative power, which was also discussed in the previous presentation. And there is burned area products, which means that the satellite will look at will compare the two overpasses and see what has burned since the last time the satellite observed this region, and then from that they can calculate the fire emissions. And of course, since the active fire is you have to observe the fire as it happens, these two products are not, you cannot mix them. They are not compatible in many ways. And of course, there are some issues with coverage because as you see, there are some white spots so you don't, it takes some time to observe the whole globe. And of course, as you get closer to the equators, the satellite overpass is less frequent than the northernmost or the on high latitudes. And of course, if you have clouds, you don't see very much. So we at the EMEP Center, we are mostly using the FIN 2.5, which is based on the burned area. There are actually two sets of emission data available, which one is based on the MODIS instrument, and that has data from year 2002 to 2023, and of course, new years will be added. And there's another set where the MODIS data are supplemented by the VIRS instrument, but they only have data from year 2014. There's also FIN 1.5, which is available, but it's sort of replaced by FIN 2.5. We also use the GFAS, which was little discussed in one of the previous talks, which is using this fire radiative power. This is also available from 2002 to 2003. And this data set will also actually have data on injection heights, for instance, and also include, of course, fire radiative power, along with the emissions of the key emitted species. If you look at how is this calculated, the FIN emissions are, of course, calculated based on the area burned, and they also have a database on the biomass at the location, and then they assume a fraction of that biomass being burned, and then of course you need an emission factor for each emitted species. The GFAS emissions, they will also have a similar emission factor, and then they will have calculate what they call a dry matter combustion rate, which is then a part of, or most of that calculation is actually dependent on the fire radiative power, but will also be, for instance, land cover dependent. So I try to look at just adding up, because we aggregate the FIN emissions to a 0.1 by 0.1 degree, which is the same as the GFAS, what GFAS actually provide from their emissions, which is also daily emissions on a 0.1 by 0.1 degree. So what I do is I simply count up the number of fires in each grid. So what is shown is actually the number of fire days in each of these 0.1 by 0.1 boxes. And you can see that there is quite a large difference between the MOD VIRS and the GFAS, both on a global and also in the actual ECHA region, which is what you've shown there, which is the region that we use for our calculations when it comes to the EMAP convention calculations, or LERTAP convention calculations. I also made a table, maybe not so easy to read, where I have calculated the number of fire days and the emissions of some of the species for different years, but also from where I compared the FIN 2.5 with MODIS and MODIS with additional information from VIRS and the GFAS, and the difference between them is is quite large actually. So you see that the difference between the GFAS and especially the MOD-VIRS is more than a doubling of almost like a tripling of the emissions, at least on the global scale. And also that the VIRS is a lot higher than the MODIS emissions. But you also see that the interannual variability is quite large for the number of fire days and also the emissions, which is so-called natural. This is actually from a very recent paper where they have looked at the fire emissions from different databases, and you actually see that the FIN, what is here called FIN 2.5, is actually the FIN with supplemented by from the data from the VIRS instrument. So they see there this data set is quite a lot higher than the other databases. So I guess without VIRS, it will be maybe on the high side compared to the others, but not quite a lot less still. So here I have looked at the effects on ozone on the top, and then PM 2.5 at the bottom. So you see that there's quite a lot of difference between the two databases. This is with MOD-VIRS, so then that explains why it's quite large, yes. And you can see that the main regions is of course sort of Africa and yeah, South America, but also the Southeast Asia or East Asian region, and to some extent also the Siberia region. This is also illustrated by this figure, that you can see that there are quite a large difference between the different emission inventories, and you can see also that especially that this is that there is quite a substantial sort of seasonal variation in the amount of fires, of course. And also I should say that the GFAS inventory, they recommend that you actually scale up the emissions for organic matter and BC but this scaling up of the emissions is dependent on meteorological driver and so on. So it's a little hard to understand why they do this. But It's of course based on how it's fitted with the model, but yeah. And also depending on not only methodological driver, but where the burning is prescribed, whether the emissions are assumed to be purely on or close to the surface, or if they are injected higher. So when it comes to the injection height, what we do in the EMAP model is actually that we only inject within the boundary layer. That is, and the reason why we do this is, of course, that we basically use the thin 2.5, where there is where you don't have the fire radiative power, so it's difficult to calculate the injection height. The GFAS inventory actually has daily information also on injection heights and so on, in addition to the fire radiative power itself. We are considering implementing injection height in the EMAP model. Actually, fire radiative power is also available now from the FIN 2.5, but only for the 2 last years, meaning 2022 and 23, and of course years as they are included in the database. The following years, I assume that it will also be available, but 2 years is really too short for us, as we also do trends, and then you need to use similar emissions for all the trend years. And I should also say that we are doing calculations for this for the European and the ECA region, which is a lot further north than your region, and the injections are probably not as high, or injections above the boundary layer is less common than at lower latitudes. But of course, we also do global calculations, so we should look at more at this. And I should say that this illustration is from Remy et al., which is actually a publication linked to this GFAS inventory and description of their inventory. Yeah. So this, as I already said, that the fire emissions are distributed even within the planetary boundary layer, and actually from the GFAS, the at least something like 85% of all the wildfires are actually emitted low within the planetary boundary layer, but this is probably less true at low latitudes, so meaning, for instance, your area. And of course, if when we implement vertical distribution of injection heights in the EMAP model, this should work, or ideally it should work independently of what emissions inventory we use, because we like to have the option of using different emission inventories. And of course, some models use injection heights estimated from NIRS, which is what I will show in the next slide. And this is from a publication from Val Martin et al. In 2018. But these monthly injection heights are only provided for a few years. And what they do is they use the results from the NIRS instruments on board the Terra satellite, which is also flying along with them, all these instruments. But one of the main problem is that global coverage takes about 1 week, and maybe even more at lower latitudes, meaning that probably you only have like 3 observations per month. And then if you average these 3 measurements, you then get a sort of a global or average for that month for a specific area. And of course, and then you use that for many types of a combination of big and small fires, which is a sort of a one size fits all. So I'm a little skeptical towards using that method. On here is some more measurements. This is PM 2.5 at 2 sites, one in Estonia and one in Latvia. Unfortunately, I couldn't really find many measurements in the Mediterranean region, which would have been more interesting for you, since there's conditions there would be at least more similar to conditions in your region than in Northern Europe. And what you see is that sometimes the result on the calculation here is with and without the wildfire emissions. And you see that in some instances, like in the left figure, the inclusion of the wildfires will improve the results, whereas on the right figure there is one particular incidence in late winter or spring, where the inclusion of fire emissions actually will not improve the results, or at least there's a specific episode where the emissions are clearly taking the results in the wrong direction. Yeah, so I think this will wrap up my presentation. And I should say that the air pollution modeling at the EMEP model has been quite a successful story for developing the policy in Europe, and actually the results from the EMEP calculations are also used by the European Union for in their work. But of course, we have had large reductions so far, but still we are not meeting the requirements with respect to adverse effects on human health and ecosystems, or actually on materials, which has probably less focus, but still. And there are still exceedances of eutrophication, ozone, and PM 2.5 compared to the WHO air quality guideline. And also, even if we use all the technical measures and additional changes, it will still be some exceedances, even with all those measures in place. We also use satellite data and data assimilation for our model emission trends analysis. But of course, it is less useful for policy development where you look at future scenarios. And of course, wildfire emissions is an important source, but there are large uncertainties. We should do more investigation in injection heights, but this is more important for lower latitudes. And again, I would also like to add that this HTAP work, hemispheric transport, this working group will actually be very happy to have more contributions from countries and regions outside the UNECE region, because this is a truly hemispheric initiative. And as I say, yes, we would like contributions from other regions. So I think that will wrap up my talk, and thank you for allowing me to present.
Okay, thank you very much, Dr. Jansson. So if there are any questions for Dr. Jansson, please use our Q&A box to type your questions, as we will now have a short time for Q&A sessions. We still not have questions from participants, so may I ask some questions? So the second slide from the last, you see the you see the comparison between observation and model simulations with no fires or GFAS or FIN 2.5, and we can see that GFAS, we cannot see the GFAS line in these two graph. So I guess in this comparison, there seems no effect from GFAS emission. But how do you think about that? How do you think about that?
Yeah, there are differences clearly, and but we also have which I didn't show because the calculations for 2022 we used the FIN 2.5, and we had some problems with very high concentration, much higher than we could see in the measurements. So it's really hard to tell which but I should also say that as I also indicated, that the GFAS actually recommend to scale up their emissions by quite a large factor, which we haven't done actually. So it's hard to tell, and fire emission is a really tough issue because and also the timing of the emissions is hard to tell. But the fire emissions is very much episodical. It's a strong emissions during a short period, but the inventories don't actually, I think, match the timing of the emissions and so on. So it takes a lot of analysis to really find out what is. But I think this is also part of this HTAP, which has a special focus on fire emissions. So it's one of the core things in that working group. So yes, and also I think the HTAP work is now sort of recommending the GFAS emissions. So
okay, thank you very much. we still no question from participants. So I have one more questions. And you talked about the injection height of the
Yes.
biomass burning, and you noted that lower latitude, for lower latitude, there is we should measure about the application of injection height for around the lower latitude. So if so, that is very informative for us. So, and especially to today's seminar, today's seminar's presenter is joined from the Singapore. So the around that region or ASEAN regions, that is a very how to say effective to effective or something, how to say, that is a very important information, and how to treat around that regions, something like ASEAN regions or Southeast Asian countries. So for some factors, apply some factors, or some not apply the injection height and emit it from the surface or something like that. How do you think about that?
Yes, I think at least for the GFAS emissions, of course,
Yes.
the injection height is actually included as a parameter, because you have these gridded emission files on 0.1 by 0.1 degree, and the emission heights or injection heights is actually supplied on the same grid, so you can use that. And on the more recent fin emissions, the fire radiative power is also included, so you can actually calculate the injection height based on that. But as I say, it's only for the 2 years, 2022 and 23. And of course, I should expect that it will be included also for 24 and the years to come. So I don't know why they have not included it in the earlier years. But I guess maybe for you it would be better to use the GFAS emissions, and I'm not really sure what we will do in the future. Fortunately, at least both FIN and GFAS are available from 2002, which is the year when the MODIS came into operation.
Okay, thank you very much. So, no questions from participants? No? So,
Dr. Johnson, if I may ask questions.
yes,
Yes.
please.
Yeah. So you mentioned about the uncertainty from the fire emission and also the height. Do you have a recommended strategy on how to quantify the uncertainty from fire emission? Because we find that it's the ultimate the final forecast is the PM 2.5 concentration, but the uncertainty in that quantity can contribute from various factors. For example, like the wind, the emission, the local emission, regional emission, and chemistry scheme. And is there a simple approach that we could apply to kind of like isolate the uncertainty coming from emission, fire emission itself, so that we can better understand the model performance?
Yeah, I think there are maybe two approaches. One, of course, is to simply, if you are able to look at this speciation of the PM 2.5, then you can get some information from that. And of course, you can, with a model, you can do a lot of experiments to see the effects of different inventories, or running the model with and without the fire emissions. And of course, you can also look at satellite measurements and also some LiDAR measurements could maybe be used if you have that to look at plumes, for instance. But I think, as I say, there are two approaches, maybe one from observation side and one from modeling side. So we have to. It's a lot of work to figure out what is what from all this information. But at least you can get quite a bit of information from that way. Actually, I do remember this fire in the late 90s, which was also actually measured in the mid-Atlantic, where you had really, really high CO values at something called Mount Pico on the Azores. So we could really, really see those fires at that time.
I see. Thank you for your suggestion.
Okay, so seems no any other questions. So thank you for your question, Mr. Chair, and most of all, thank you to our speakers. The second session of our seminar is now over. I'll hand it back to you, Dr. Yamashita.
Thank you, Dr. Kiriyama. So let's move on to the closing session. I would now like to invite Dr. Toshimasa Ohara, Director General of ECAP, to share the closing remarks. Dr. Ohara, please.
Okay, thank you very much. Thank you very much for attending the EANET seminar for Particulate Matter Problem, including Haze in Southeast Asia. As you know, the fine particulate matter has a very long lifetime with a few days in the air, causing a regional scale pollution, crossing national borders, and pushing up the average concentrations across the entire Southeast Asia regions. And also, there are many kinds of chemical compounds and emission sources, not only primary particles, but also secondary particles. In this situation, it's important and a common challenge for all countries in this region to gain a better understanding of current status of PM haze pollution and explore the best solution for the reduction. Today, we were able to learn a lot science-based experiences and valuable information, fire emission inventories and modeling in EMAP as presented by Dr. Jansson, and socioeconomic science-based knowledge by Dr. Dusman, air quality modeling by Mr. Chia, and second ASEAN haze-free roadmap by Mr. Prananta. Thank you very much, all speakers. And we hope this workshop will serve as a good opportunity to strengthen the collaboration between EANET and the ASEAN Agreement on Transboundary Haze Pollution, as both share the same direction in improving air quality in Southeast Asia. Thank you for your attention. That's all.
Thank you very much, Dr. Ohara, for your closing remarks. Our seminar is now adjourned. Thank you for all for taking the time to participate in our online seminar today. Before you go, we'd like you to share your quick feedback through this online survey. Please find the link in the chat box. You can answer within a few minutes for the questionnaire. So please have a wonderful rest of your day, and we look forward to our next event together. Thank you very much.